Go. All right. So the first thing you need to do is choose an equation and solve for one variable. Now, what do I mean? How do you solve for a variable? Because when you say solve it, you are usually trying to find the answer, yes? And yet we know that when there are two unknowns, we cannot find an answer, can we? So solving for a variable means to isolate one of your variables. Now, of course, I am using x and y because that's what we're used to. But does it have to be x and y? No, of course not. So step one is choose one equation and solve for one variable. I even give you this handy hint. Choose a variable with a coefficient of 1 or negative 1. Now, which of these two equations satisfies that condition? The first one. So I'm going to make him the red one, and I'm going to isolate one of those variables. Now, some of you are actually going to isolate y. I don't know why you would ever... I do know why you would ever do that, because you think, oh, I got to put it in slope-intercept form. No. Isolate the easier one. Do you notice how x is already all by itself? So let's isolate x. What would I have to do to get x alone? Well, you'd probably have to take it out to dinner, maybe.
Wow.
You hear what I did there? I'm trying the jokes again because it's Christmas.
Wow.
They seem to have failed again. Oh, well. All right, so how do I isolate? How do I get x alone? There was even a song from like 1994. How do I get you alone? It was by a band named Heart. They're from Seattle. Anyways, how do I get x alone? Jacqueline. I would move x to the other side of the equation. I would move y to the other side of the equation. So this becomes x equals 4y minus 1. Does everyone agree? All right, now I'm changing color to blue. Take the new equation. Where is that new equation? It's right here. Because this equation isn't anywhere in our question, is it? Not in that form. That's new, right? And then we substitute it into the other equation. What? What do you mean by that, Mr. Myers? Well, this blue line says that x is 4y minus 1, correct? What do you see right there? X. Well, x used to be unknown, but now we know what x is. What is x? 4y minus 1. So I take this and I put it in there. So I get 3, not x. What do I get?
4y minus 1.
Minus 1 plus 5y equals 31. Huh? Now notice what has happened. We couldn't solve it before because there were too many variables. How many variables do I have now? Only one, so we can solve it, can't we? In green, we will solve for the remaining variable. So we're going to run this. What is 3 times 4y? Minus 3 times 1 is 3. Plus 5y equals 31, yes? What do I do with that and that? I combine like terms to get 17y minus 3 equals 31. What do I do with that minus 3? I move it to the other side because I'm trying to isolate y. 17y equals 34. And what is my last move? Which is 2. Huh? And then plug your solution into one of the original equations. Well, we know that y equals 2, yes? So what do we still not know? We don't know what x is, correct? But I have a y equals 2 right here. Now, if I go right back up to that equation, will that leave me with x? So that says x is 4y minus 1, but I can't solve that because I don't know what y is. But I do know what y is.
Yeah.
What is y?
2.
So x equals 4 times y, but not y because y is 2 minus 1. What is 4 times 2? 8. What is 8 minus 1? 7. So what is my ordered pair that is the correct answer? 7, 2. Now, would any of you dream of coming up to me and saying, did I do it right? Did I do it right?
No.
Of course not, because that 7 is an X, isn't it?
Correct.
What letter is that?
X.
So what do I write there?
7.
7. That number 2 represents what letter? What letter is that?
Y.
What do I write there? 2. What's 7 minus 4 times 2?
-1.
-1. So I'm correct. What is 3 times 7?
21.
What is 5 times 2? What is 21 plus 10?
31.
So am I right?
Correct.
Well done.
I scored.
Not complicated. Go to the next one.
I should watch.
Who will I isolate first? Red? Well, wait, we'll do it this way. Yellow or blue? You want to work with the blue one?
Oh, yeah.
Might I ask why, Jacqueline?
Because it has a 1 and 1 is easier to work with than 3.
I would agree with you there, except we're trying to get variables by themselves, aren't we? So I would submit that that y is sitting there all by itself. But we could still do it doing the blue one. Let's do the yellow one, and then I'll show you very quickly how you could still do it with the blue one. Okay? So what are we going to do with that yellow equation? Because red was the first step. What are we doing? Yes, Simrith? You're going to make a new equation. And that new equation will be what? There's a trick you can do here to make it easier on yourselves. What has to move to get y by itself? The 2x, right? So if we move that over, some of you are going to write this. -2x plus 3. I don't like it, because that negative messes with your heads at the front. I like to write it this way. 3 minus 2x. But does it matter? Of course not. There is my new equation that Simrith said we should find. Now, I believe I used blue next. What do I do with that new equation? I substitute it into the other equation. I can't put it back in here because it's the same equation. It'll get me a bunch of zeros. So 4x, because x hasn't changed, plus 3 is y, still a y? What is y now? 3 minus 2x equals 1. Then I solve this one. 4x plus 9 minus 6x equals 1. What do I do with 4 and 6? What is 4 minus 6? -2x plus 9 equals 1. What do I do with this positive 9? I move it over here, and what does it become? I subtract 9, and I get negative 2x equals negative 8. What does x equal? 4. Then my next color is... Oh, I screwed that up. I should have been doing the... This should have all been green. Sorry, everyone. Then what do I do with that 4? I have an x. What am I missing? A y. Do I have any equations that tell me what y is? The yellow highlighted one. So y equals 3 minus 2, not x. What's x now? 4. 3 minus 8 is negative 5. What is my ordered pair that is my answer? 4, negative 5. Mr. Mize, did I do it right? Did you, kid? What's 2 times 4? 8. What's 8 plus negative 5? Which is 8 minus 5? Just 3. So I did it right. What's 4 times 5? 20. And what is 4 times 4? What's 4 times 4? 16. What's 3 times negative 5? 16 minus 15 is 1, so I did it right. Yeah? All right. Turn the page over and tell me what... Oh, wait! I said, Jacqueline, if you wanted to work with this one, you would have had 3y equaled 1 minus 4x. Y equals 1/3 minus 4/3 x, right? And then that would go in here, and you'd solve.
Only those with grade 11s with form, please head down. Thank you.
Okay. What's weird about this third example? There's no variable with 1. So we are going to be stuck with fractions unless we can think of something else we can do. What do you see there? They're both 4x. Bye, Anita. So, what is something we could do here? Braden? We could get rid of 4 by dividing it out, yes. But then we're going to have a bunch of fractions. And what do fractions do to you people? They scare you. Right? Pardon me? Gershill? Oh, okay. Okay. We're trying to get rid of something, right? Okay. I'm going to do something here because nobody came up with it, and that's okay. I didn't totally expect you to. Ah, son of a bee. What is going on, you piece of garbage? Watch this. I'm going to use a color that I haven't used before. Doesn't 4x equal 2 minus 5y? Doesn't it?
Yes.
Okay. And doesn't 4x equal negative 3 plus 20y? Doesn't it? Now, if 4x equals that and 4x equals that, what do I know about those two? They're different? They're the same. So doesn't that mean that 2 minus 5y equals negative 3 minus 20y? Because doesn't that equal 4x? Right there. And doesn't that equal 4x right there? So if 4x equals 4x, which it does, don't the two equations also have to equal each other? And what does that give us? Well, once again, it got rid of the x, didn't it? Now, could we have isolated? Yeah. Could we have done the work? Yeah, we're smart. But we notice if there's two things the same, we can just make them equal each other and we're in business. Everybody cool? So what would I do here? Obviously, I would solve this. I can get letters to one side, numbers to the other. Does it matter where they go? No, of course not. I shouldn't say that. If I'm unsure, I like to remember this little mnemonic device. L equals N. Letters have to equal the numbers, and I put the letters on the left. Now, obviously, I don't do that. I can work with negatives and fractions just fine. But my students often like to have that to remember. So, if we're going to go by that, and I saw your hand, Jacqueline, please ask your question. A thank you. It is indeed positive 20. Now, if Jacqueline hadn't reminded me of that, and I did all this work and got an ordered pair, would I have handed it in wrong? No, I wouldn't have, Gersa Hill, because of course, what would I have done as a last step that I did both of these times? I would have checked my ordered pair, right? Okay, so if I'm going to move my letters to the left and my numbers to the right, what moves? The 5 or the 20? The 20. It's going to come over here and become negative 20y minus 5y equals, my number is going to come over here, negative 3 minus 2. What is negative 20 minus 5? Minus 25y equals, negative 3 minus 2 is negative 5. Y equals negative 5 over negative 25, which is positive 1/5. Everybody cool? We're still stuck with a fraction. I know it's hurtful, but let's look back up at all of our choices. Where is a good spot that I could put 1/5 for y? Look at all your options. Where is there a spot where I can put 1/5 for y and have it work beautifully? It would work with the 20, because then you're going to end up with 20 over 5, right? It would also work with the 5, because then you're going to eliminate the 5s, yeah? So I'm going to take that guy, and I'm going to move him up there to get 4x equals 2 minus 5 times what? 1 over 5. What happens to those two 5s? What happens? They cancel out. 4x equals 2 minus 1. What's 2 minus 1? It's not a trick question. 2 minus 1 is 2. 1. X equals 1/4. So what is my ordered pair now? What's my ordered pair? 1/4 and 1/5. And let's check. What's 4 times 1/4? 1. What's 5 times 1/5? 1. What's 1 plus 1? Are we right? Yeah. What's 4 times 1/4? 1. What's 20 times 1/5? 4. What's 1 minus 4? -3. Are we right? Now, if I did that step and it didn't work, then I know I've done it wrong. What would I do? Go back and find my mistake. Would I have found that -20? Yes. Everybody cool? Pretty easy, right? Okay. I have for you 8 to try that are boring and lame. But then
We get a fun page.
I have a fun page.
It's cut off. It's cut off.
Shut up your face, really?
Yeah, so we don't know the letters. So we can't.
Those sons of bees. All the numbers are there, though?
Yeah.
Oh, I hate those people. But all the numbers are there, and it stops at, oh, you've got 2 12s at the bottom, so you can almost fit it in. Here are the letters. Write them in. It doesn't say P anywhere. Oh, it does say peed. Oh. I'll highlight it in yellow. Oh, that font came with the sheet. These worksheets, I know that all of you have used these puzzle sheets in previous classes. They're from like the 1970s.
Why is everything used twice? Oh, I get it. Why does the president put vegetables in his blender? To make a smoothie?
To make a smooth pea. I watched Elf last night.
I'm sorry.
I had forgotten about that gag in it where they bring in this children's book author and the guy says, what if it's a book about vegetables and they're all asparagus and they're embarrassed because of the way their pea smells? It was so funny. I wouldn't say it's the greatest movie, but
It's actually a shadow.
it's pretty funny. The way he makes the Christmas tree out of the elevator buttons. All right, go. There are none of them in our